Name a better car that we could have gotten. The Rebel. Yeah, wind tunnel twice before, but never one like this. This one's supposed to be pretty cool. It's to dial in the Kona setup is the reason why we're here at the wind tunnel. And it's basically just being able to walk away at the end of this trip knowing what the fastest setup will be. And then if I change anything, what those changes would either cost me. I think that we could potentially see some changes in the front end for sure, because we raised my front end by about 1 centimeter. So I also kind of want to see what the difference is between just having one bottle behind me on the bike versus two. And so the factory race team just shifted in what it was. They just condensed where they had a lot of different Trek athletes. Some were on the factory, some were just considered Trek athletes, but they were all out of the race shop. They had us there on all SRAM products. The wheels section opened up to allow me to be able to come out here and be able to work with Zipp. How's it going?
My name is Ruan Trow. I spent last 10 years here at Zipp. So I now have the quality engineers and also our factory manufacturing engineers. So this is our disc area, the honeycomb structure with carbon skins on the outside. It gets autoclave cured. And then we machine and bond in the hubs over on this side. This whole side of our wall is temperature and humidity control.
So how many pieces of carbon would like a wheel?
It depends on the model. So depending on like an NSW product, a lot of them have patches for spoke hole reinforcement. And so if you have 24 holes, you have at least 24 patches, in some cases double that. So our factory runs off of a pull system. When you place an order, we'll pull from that supermarket, build that product, and then that supermarket will place an order. So we only make what's needed.
Welcome to the test lab. Kind of starts out with a bunch of non-destructive type things. So we bring wheels in from the design, the manufacturing teams. We'll kind of go through a characterization process. So like runouts, tensions, kind of baseline the wheels. And then they get tires installed, they get set up tubeless. You have a whole bank of test tires. Back there, actually, we have a little bench, so we'll do a lot of like field testing to try to correlate to our test methods, better understand, what's actually happening in the field compared to, what our tests in the lab are doing. And then from there, we just kind of move into a bunch of durability test machines. This one, actually, this is what we call a driving durability machine. And what it does is it simulates like a sinusoidal pedal load. So as you're pedaling on your rear wheel, through the driver body, it's not just like a constant held load. With that pedal cycle, it creates like a sinusoidal load. It's cool when we actually get like field data or like real data, because then it helps kind of validate what we're doing in here. Yeah, I mean, we've played with the different like combinations of loads, like the radial load or the wheel pushing down, and then the force from the lateral roller. We've kind of played with that. Got the whole 3D printer farm too here, but we'll do a lot as far as like manufacturing tools as we're trying new designs. So for a quicker turnaround, we'll actually 3D print certain tools in-house. Okay. And then we have the rolling road, so it's our riding treadmill. 87 slats, and we can change them with, I think there's 5 different heights of those the white plastic slats we can put on there. So we can simulate different terrains. So the wheel testing, it's really for like that comfort, that compliance, vibration damping for the gravel and the off-road stuff. And then it's like power studies for more of the on-road. So it'll do 25 miles an hour. It'll do incline and decline. But we'll use the high-speed cameras. The high-speed is good for like any of the testing that we do to better understand stuff.
Well, that was cool. Just coming out of the Zipp factory, I think it's always interesting to see how the products are made, especially when it's carbon fiber, because so much more involved process, I think, than when you just look at a wheel. You might think, oh, it's just sheets and then they just press it in, but it's like sheets that are cut down and woven together and just placed all in handmade too, which I think is something that's really cool and goes along with the quality of the product. We're also going to the wind tunnel tomorrow, obviously, which is one of the other reasons why we're here. And it's always been Park and myself who've been the main drivers, and just, the team at the wind tunnel just kind of facilitates how they can. But the Zipp team was really great in like sitting down and figuring out exactly what we needed to be successful tomorrow. So for the rest of the day, now that all that's at least planned out, we're gonna make sure the bikes are good to go and just being able to squeeze in as many runs as possible to get as much data as we can. And I'll squeeze in a run here before we go to dinner. So just on the way to the wind tunnel, got the bike set up and now we just gotta ride them. I mean, yeah, speed is always one of the main purposes, but just wanna be able to push big watts for as long as possible to try and dial in the hydration setup. This will be my third time. First 2 times we're at A2, and then, yeah, this will be first time at one like this. Driving into a wind tunnel like this though, I feel like they're all the same in that they're in an industrial park or out in the middle of nowhere or something, and you roll up and it doesn't look super special on the outside, and then you walk in and it looks like a spaceship. Good morning. How's it going?
Good, how you doing?
Good.
So Ben is wearing a chest strap with an accelerometer built into it. It shows me his torso angle, it shows me how his body is moving using the accelerometer in 3 different axes. And then I can see his heart rate and his breath rate. What we don't want to do with his position is make a change that increases his breath rate and his heart rate for the same load. So there's no point in working on pure aerodynamics when it could be having a metabolic effect. So what we're trying to do is make sure and control the position, control the effect on his breathing, heart rate, body temperature, and all those things. So we want to keep those things balanced throughout the testing. So 100 grams of drag is a second per kilometer.
Okay.
In raw terms.
Which yaw angle do you want to look at most?
Between the negative 0.5 positive, well, probably the 5 to 7.5 is most relevant. So Ben, between the 2 helmets,
Yeah.
between
2 watts.
2 watts across the boards, better.
2 watts better.
Yeah.
And I think this one is probably more versatile if we go higher versus the other helmet, because this one helps with the back more versus the other one. If we bump the head up too high with the other one, it doesn't really help as much.
Okay.
2 watts,
Yep.
2 watts, yeah.
The first 2 watts of the day.
Yeah. You don't want the torque.
I have to adjust those.
So I think the movie.
Yeah.
Next lap, Kate. I would say you've lost hydration, and it's relatively neutral except at the positive 5 yaw angle where it's worth about 5 watts. Do you guys concur?
I agree.
with that? Yeah.
Okay.
I guess the only thing that I'm curious about is how much impact do you think the angle of the bottle not being perfect right now is making? Like if we were able to zero that, do you think we're talking a significant change in drag with that?
I think you'll see more variation from bike to bike than you would from adjusting that bottle.
Yeah.
I think for this, it kind of feels like sliding back. I mean, we wanted to come up regardless, so I don't have a comparison for if we go up.
I think get him comfortable to where he feels. I think the arrow's there.
Yeah.
I don't think there's really that big of a penalty. Is the angle set? Are you staying with the same angle there?
So how would you say comfort is between this and the other one?
This one, I think, could be more comfortable if it was a little bit higher. I
Okay.
can see how it would be because of the way that the angle is, but I think with the angle being that extreme and I'm down low, it's slipping down on the
Okay.
pads.
Okay, let's do 1 centimeter up, see do we increase comfort, keep drag neutral, and then we look at tilt.
Okay. Yep.
Okay, let's do it. Cool.
Pretty good.
Okay.
I'll be somewhere in the middle.
Yeah.
So how about this? We have to know what the bottles do. We have to know what the helmet does. Let's get the things done we need to get done and then come back to the front end. Here's where we are now. Ben's 2 cents is, well, You know, so we're about 3 centimeters higher, 15 mils longer, and 10 degrees more
So I can
tilt.
tell you right now, like the deltoids to hold it.
Yeah.
I mean, it's new, but that's probably the biggest change there. Is it's
Right.
definitely more stress. But my question is, I mean, we've gotten faster the more that I've come up and had the angle. Like, I just feel like we were talking about, once you know, or maybe I was talking about it with Lewis, but like, if you know how high you can go when it breaks, like maybe we only stay at this position for the next few weeks while I get used to it, but maybe we decide, okay, I want to go up a little higher, like work my way into it. We just right now don't know how high we can go for when that'll start to see no return or negative return.
We're 40 mils higher, 15 mils longer. We can keep going, but it's like in a perfect world, you'd have to be adapted before we can really measure it. And we have these other questions to answer, and we have a finite amount of time.
And we also don't have another wind tunnel time to come back. Adapting, like I've ridden road bike, like I feel like I can take the adaptation. I agree that if I'm going to go out and train hard, maybe we have to work into it. But if we don't have the data now, we can't make an informed choice 6 weeks from now when we're going, do we need to go up a bit higher?
We can keep going. We're in an unconventional place in terms of how high we're coming. So
I'm okay with unconventional if it's fast and comfortable. And I mean, they did the opposite of what we thought it would do. We thought it would be slower to come up, so we just haven't found.
When we looked at this and saw how you're shielded, we were pretty sure this was going to be fast.
Yeah,
That angle
it took
plate
us
is
like
neutral.
working up to do that. So then my question is, if we switch now, because Park wants to make sure we get helmet, bottle set up, like to get all of that data. But if we keep pushing higher, is that going to mess with the wake? Like if I put 3 bottles on the back or 2 bottles on the back?
I think everything on the back end on the trailing end is going to be marginal. Getting everything you can up front to get that air flowing around you, keep that attached as long as possible,
Okay.
the better off you're going to be.
Okay.
The biggest thing that you've done is that angle. That BT8 is nestled in there so well. It is shielded at almost all the yaw points.
So then, I mean, I think we're 100% certain on the angle.
Yes.
The angle is going to stay.
Yes.
It's just, for me, how high, and then also just, I mean, width might be something that's a little bit later that we do, but just the height and just that final comfort.
Your heart rate's elevating a little bit because it's getting hotter.
Yeah, that's fine.
But breath rate, stable, torso angle. Pretty much every single change we've made, each change has changed your torso angle by 1 degree.
So, but I agree with you. We just want to make sure we have time for that last minute stuff and that's all. I mean, that's what this trip is about, is making informed decisions, right?
Slower or faster?
Faster.
Each time's gonna be faster.
We can figure out some hydration things, but there's no penalty. So he's breathing better, he's more comfortable, he's got more surface area contact between his elbow to his forearm, wrist is locked and neutral, less strain on head, neck and shoulders, less load on his lumbar spine, which is the area that we're trying to make sure is 100%. Yeah, we have data on that before. His breath rate doesn't look like it's much different, but we'll know straight away once he starts riding outside.
Yeah.
The wind is coming now.
Comfortable like that. If I get uncomfortable in that position and I start pushing 15 less watts or 20 less watts by the end, or I can't take in nutrition, then it doesn't matter if I'm losing a couple.
So your heart rate is lower by 2.
Right, yeah, so
And your breath rate is better by 4.
The 5, 7.5, and 10 showed marginal difference, so I don't know that there's value in that as much, especially at the 0. We got the side angle, everything's up in terms of watts.
3 bottles.
if you can fit, if we can fit 3, let's try for 3 then, just to see, because that should essentially be similar to 2.
Yeah. So 3 bottles.
Or do we want calf sleeves and socks?
that helmet versus a road helmet, 20 watts. What if your FTP is 220? It's 10%.
Yeah, I know.
It's massive.
It's significant.
Everybody here, when you were up there, was remarking, holy shit, he's consistent, he's quiet. But that's all the work with Pendola, it's all the things you do that make you who you are. It's cool that you guys see that.
Yeah, that was super successful. The team did a great job getting me up and running. We had, Zipp, Park, wind tunnel guys here, and just everything went super smooth and ended up, raising myself up 3 centimeters, I think, tilting more and actually getting more aero in doing all of that and more comfortable. So objectives achieved. We confirmed that the 3 water bottles behind, if I wanted to run that, doesn't really affect the aerodynamics that much. And also found Santini calf sleeves a little bit faster for me, which is not usually the case. We tested another pair of socks, and I've tested other calf sleeves in the past that weren't faster, so some cool stuff. And then just, got the data for the different helmets as well. Everything went relatively smooth. The changes were quick. We made the most of our time. I think I was pushing a little too hard on the pedals. A couple of times the electric motor didn't like that, but overall, we didn't have to make any concessions during the day. We got in everything we wanted, pushed the limits a little bit, and then got myself pretty much exactly where I'll be in Kona, where we might make a few adjustments, just that we don't need the wind tunnel for necessarily, but for the major changes that we've made, we've confirmed it all and have the data now. This is the smoothest and best collaboration. Everybody works well together. People had good ideas. We implemented them. Everybody was super positive, and it's not a short amount of time we're here, 4 or 5 hours doing run after run. So that was super awesome to see, and just it made it easy for us to dial into what we needed and get it done. This is just kind of confidence in general, just knowing that the position is good. It's in a spot that I'm comfortable with. Now I can go out and do the training and make sure that it's applicable to the outdoor conditions. And the next step is going to Kona to do a little camp to make sure that when I'm riding in the position, in the heat, in humidity, and at the watts that I want to race at, that everything is good and solid and works well. So now we've done all, and we have all the knowledge to make the choices. Now it's making those choices and making, educated choices, not just guesses. I think by position-wise and aero socks, we're probably in the range of 7 watts. Am I close on that part? 7 watts?
I think it's closer to 10 or 11.
Okay, closer to 10 or 11 watts, which whenever you can hit double digits at the wind tunnel, that's massive. So we have some room to play around with here. I think we probably should go and look at the data to get exact numbers with CDA, and so I'm not just gonna, yell stuff out, but honestly, anytime you can save up to 10 watts is just free speed, and that's awesome because we're doing it when I'm more comfortable as well. So.
Hi, my name is Pádraig McLean. I'm the CEO of Cyclologic, a bike store in Scottsdale that specializes in bike fit, and the CEO of Velogic Fit, which is a cycling software analysis company. So Ben and I have been working with each other since, just after the Rio Olympics, and today was the kind of culmination of 8 years of working together and specific preparation for Kona. Ben has obviously focused on 70.3 for a long time, so our objectives today were really simple. One, we wanted to see could we find some speed, but we wanted to find that speed in the context of making sure that we actually upgraded his comfort. To accomplish that, we completely re-engineered the front cockpit on the bike. We put a Sync custom aero bar into the mix. We rejigged his BTA system in order to give him what we needed from a hydration perspective. And then we tested different hydration configurations in order to make sure that all that worked. In addition to that, the other things that we worked on were making sure that his breath rate and his ventilatory mechanics didn't suffer from any of the things we did. So we use a system that measures breath rate, heart rate, HRV, and his torso angle to make sure the position that we created was sustainable. So with the extra rigors and demands of Kona, that Ben's going to have the best race he possibly can. When you're working in a wind tunnel, there's always challenges and roadblocks and things you think are going to produce results that don't. The thing with aerodynamics is you never know actually what's going to happen until you test it, and sometimes the things you think that are going to be amazing just are unremarkable. No, we had the perfect amount of time. The thing with a wind tunnel test is at a certain point the athlete just gets fatigued, and we were right at that point with Ben. So the right amount of time in the wind tunnel is the right amount of time that you can get quality data. So we did fine with the right amount of time. In terms of did we get what we came to get? We absolutely did. For me, as somebody who's spent hundreds of hours in the wind tunnel working with lots of athletes, it's actually really stressful coming to the wind tunnel, because I know the athlete has expectations that they're going to get faster, that we're going to find innovative things. Today we did. Today we found significant comfort, significant change in overall stress and load on the body, and we found aerodynamic change, and that's kind of the holy grail that you want to find when you come to the wind tunnel. So one of the things that was really cool about today is sometimes when you come to a wind tunnel or you start working with other partners or other sponsors, the folks at Zipp were amazing, the folks here at ARC Research were amazing, and we had a great synergy between all the different levels of expertise. The data was super clear, all of the runs we netted gains, we had an amazing team from Zipp, we had an amazing team from the wind tunnel, and then obviously Ben and Slowtwitch were here to make this incredible. So sometimes that doesn't work great. Today was amazing.